In this video, we're going to talk about the 3 pillars of programming. These are 3 statements or control structures or aspects of programming that you're going to do the rest of your life as a programmer. And they're called sequencing, selection, and iteration. So these are the 3 pillars. And the first one is sequencing. Now watch how I show you sequencing. One statement after another. Seriously, that's it. Sequencing is doing things one step at a time. You execute a command, you execute another command, you execute a command, you execute another command. That's it. That's what sequencing is. It's putting steps in order that make sense to achieve a result. That's it. You can sequence, if you think back to what you did this morning when you woke up and your alarm clock went off, you could sequence everything you did between that and walking out the front door. Or in COVID-19, walking to your living room to sit on the couch and eat Cheetos all day. But sequencing is literally one thing after another. That's it. That's the easy one. Selection is basically deciding if I'm going to go left or right. It's that simple. Okay? Or if I'm going to go left or then do nothing and go to the next instruction. Okay? So the most fundamental selection statement is an if statement. And it's basically if whatever this evaluation is true, I'm going to do this. That's it. When I'm done doing that, I'm going to go to the next statement. If it's false, I'm just going to go to the next statement. So if something is true, I'm going to go do this, then I'm going to pick up where I left off. If it's false, I'm just going to pick up where I left off. Okay? That's an if statement. Now, there it is. If something's true, do something. But then we have the case where if it's true, I want to do this. If it's false, I want to do this. Then I want to move on. Okay? And that's called an if, and then we'll do something, and then there's an else. Okay? And an else doesn't need its own expression. This is a little bit misleading the way I type this, because else doesn't need anything after it, because it's this expression was false. But I put it in there just so I could say the expression was false. So if this is true, do this. Otherwise, do something different, and then pick up where I left off. Okay? Now, you can nest these things, and they can get ugly. And some languages have this thing called elif, E-L-I-F, meaning if this is true, do this. Elif, else, if this is true, do this. Else, do this. And they can get very, very convoluted. And what I tell people is if you need more than 2 nests, you need to be in a switch statement. Okay? And a switch statement in C allows us to have different constant expressions based on the values to do things. So let's say I have an integer that's going to represent a menu choice that someone makes. They're either going to press 1, 2, 3, 4, or 9 to quit. Okay? And if they press any other key, I've got it error trapping so that it just replays the menu again. Okay, so you can monkey mash the keyboard and it's going to keep showing you the menu, but if you hit 1, 2, 3, 4, it'll do the right menu option for those. 9 quits. Okay? So I can say switch on the key pressed, right? And if the key pressed is a 1, which is a constant because it's a literal, if it's 1, do this. And then when you're done, fall out of it so that you go back and show the menu again. But if it's a 9, okay, then you're going to quit. Okay? So if it's a 1, you're going to go run this part of the program and then break out of the control structure, show the menu again. If it's a 2, you're going to do a different part, 3 different part, 4 different part, 9, you're going to quit. And I can have a default where there's just statements, and the default might just be run the menu again. So that if I hit a J, which isn't even in the menu, it just shows the menu again. Okay? So a switch statement allows you to select based on more than true or false in a Boolean expression. Okay? So I can switch on a variable that may have 52 different values. Now, the danger is what's called fall through. If I don't have these breaks, okay, it's going to execute all of these statements till it gets to the end. All right? So if I only wanted to do a certain thing and then pop out, then I need these break statements. Those are the only places I ever want to see a break. Okay, because syntactically they're required, and they're actually optional in here, because there may be a case where if I pick 7, I wanted to do the last 3. Okay, so they're technically optional statements, but it's going to fall through and execute from there below if you don't have a break statement. Okay, so the way we're going to use it in this class, the way my expectations are, you're going to have a break statement for everything. You do not technically need it for default, because that is last. And again, this is syntactical. We'll show you this in the code. It exists in most languages except Python. And I don't know why they don't have a switch in Python. They should. But basically, that's a switch statement. It is selection. Okay, it's selection based on more than a binary choice. So we have if else. We can nest the if else's as much as we need. But when it gets really confusing, we should move to a switch. And that is selection. So we have sequencing, which is do this, 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 this. We have selection, which is, okay, if this is true, we're going to go this way. If it's false, we're going this way. Or here's 3 choices, and we're going to go this way. And then pick up where we left off. And the final one we have, oh, I'm sorry. There is one more thing I want to show you with selection. And this is syntactical, and this is getting a little bit into the language, but I want to put it in here, and I'm actually glad I added this last night. It's called the ternary operator. And this is a way of very efficiently doing an if test to set values. Okay? Because a lot of times what you're going to do is you're going to say, if this is true, this particular variable gets this value, or it gets this value if it's false. So rather than have to type a whole if-else statement, you can say condition, question mark, the value if it's true, or the colon, and then the value if it's false. Okay? That's called the ternary operator. So let's say I have int x equals 8. And I can say int answer equals, okay, so this is another variable, and it's being assigned whatever this evaluates to. So it's going to evaluate to, does x equal 4? Now this is equals equals. This is the assignment operator. This means, is this equal to that? Okay? Equals equals means, now I'm saying, is it equal? Okay? Is x equal to 4? And that's why the question mark goes there. Goes, is it? Is x equal to 4? No, it's not. So it's false. So 123 is what's assigned to answer. Now, if I'd wanted to do that with if else, it would have been if x equals 4, answer equals 99. Else, answer equals 123. Whereas here I can say if answer equals x equals 4, 99, 123. Okay? So ternary operators are really cool. They can save you a lot of time and a lot of hassle and a lot of if-else's if all you're doing is setting a value to a variable based on another condition. Okay? So this is kind of cool. Not taught in a lot of high schools that I know of, but it's a very cool operator. And you can do it in C. All right, so 123 because x is, bang equals means not equals. So if I had said x bang equals 4, I would have said, is x not equal to 4? And the answer would have been true, so then 99 would have gone in. Okay? So bang equals means not equals. And I think I even highlight these. That means equals to, and bang equals means is not equal to. Okay? So now let's talk about iteration. And here, because of time, I'm not going to go into the syntax of these. But iteration is the academic snootery term for looping, repeating code. Okay? That's all it is. When you hear iteration, think loops. All right? There's 3 forms. There's 4 loops, not to be confused with 5 loops and 3 loops. That's a bad joke. Okay? 4 loops. 4 loops. There is do while. And the interesting thing about do whiles are they always execute at least one time. Whatever's in that block of the do while is executed once at least. And after the do while we have the while do. And the difference between these is where is the conditional that terminates the loop evaluated. In a do while it's going to execute this code and then say, is this bottom condition true? Okay? If it is, I'm going to keep looping. The minute it becomes false, I'm dropping out. Okay? And in a while do, that evaluation occurs before it gets to the loop. Okay? So, really common assessment question. Which type of looping always executes at least once? It's a do while. Okay. Now, we've talked about sequencing, selection, and looping, or iteration. Where do these come from? They come from the Böhm-Jacopini Theorem. And basically this theorem says that all programs can be written using nothing but these statements: sequencing, selection, and iteration. So if you have those abilities, you can write any program that you need to write. Okay? That's it. Now, every year, I have 1 or 2 of my little power coders that come to me and try to make the case that go-to statements, where you're literally jumping to a different part of your code, are valuable, and that they're okay, and that they're necessary. Okay? And so I put this in here just for the power coders, and I'll read this because it's pretty small on the screen. For you power nerds who like to think go-to statements are not evil, which they are, and I simplified this from a Stack Overflow comment that was very enlightened. And this guy put it very well, and I simplified it a little bit. The operations and structures that these 3 things provide us can easily be shown capable of replicating the function of a Turing machine. So by definition, it is a Turing equivalent system of computation. By the Church-Turing thesis, this is believed to be as much computation as we can do. Go-to statements would add nothing that is not already possible. Now, Alan Turing basically is the father of modern computing. His Turing machine is a theoretical computer. And anything that they created under their Church-Turing thesis, if you are a Turing equivalent computational power, it means that you've achieved what they did with the Turing machine. And it's pretty much all the computing we can do with a physical computer. And so these are all you need. And go-tos are hard jumps that are not part of this. And without getting into deeper theory, because it's way outside the scope of this course, just understand that they've been arguing this for years, okay? And the reality is the Böhm-Jacopini theorem is right. It's a Turing equivalent, and all you need is sequencing, selection, and iteration. You can write any program. You should not have to use hard go-to statements in your code. You should not need those jumps, okay? And I've been writing code for a very long amount of time, and I've been teaching this for quite a while, and I can tell you that when I see go-tos, It's generally, in reality, at a student level, coming from a place of not understanding methods and parameter calls and return values from functions more than it is they're really trying to make this fight. Okay? So go-to statements are not needed, and therefore they will not be graded very well. Okay? And I'm not going to get into any more of that than this, but every year I get one or two, so I just kind of wanted to nip that in the bud. All right. That is the end of the slides that I have right now, pre-language C. See, I'm on to the next slide. So what we're going to do is we're going to begin to do a hello world next. And so we're going to begin to learn the language C, and that will unpack a lot of what you've already seen and a lot of what we're going to continue to do. Those videos will actually be in the C language chart. They were in the playlist on YouTube. So those videos you'll see under the C language series. Okay? I would like you to go there next, because the following videos in here are going to be post C, and then they will begin to set us up for some of the Python and maybe even some of the web development videos we're going to need towards the end of the year. So for now, that is as far as you need to go in this playlist. This will be, I'll call this part 1. And so from here, I want you to jump to the C language playlist next. Okay? I will see you in that playlist on the other side.